Welcome to Module 2 of the COSI Statistics Institute. In this activity, students develop their understanding of least squares regression in the context of modeling fire spread. This activity assumes that students have seen scatter plots and are comfortable with describing the relationship between two variables based on the scatter plot. Part 1 of this activity should take students about 10 to 15 minutes to complete. Let's get started with a bit of background. Wildfires pose a huge threat to people and property in California, across the U.S., and around the world. The ability to predict how a wildfire will spread is an important tool in fighting wildfires. Give students a minute to read the background information given at the beginning of the activity. It's often a good idea to get an activity started in a way that engages students with the context. Part 1 of this activity does this by asking 2 questions that can be the basis of a brief class discussion. You can start by having students share ideas on why it's important to predict the spread of a fire. Typical student answers include that it would allow firefighters to determine where to build fire lines, and that it would help officials decide when and where to issue evacuation orders for residents. The second question encourages students to think about what variables might affect the spread of a fire. Students can brainstorm ideas. If you're teaching online, you can have students enter their ideas into the chat window and read out some of the responses as they come in. A few of the typical student answers include wind speed, wind direction, humidity, temperature, type of vegetation in the area of the fire, and how long it's been since there was a previous fire in the area. After the initial discussion, the activity introduces the first data set that will be used in this activity. This is a small data set from an experiment that looked at the effect of wind speed and moisture content of the vegetation that fuels the fire on how quickly the fire spreads. In this first part of the activity, students just consider wind speed, so all of the data is for one fuel moisture content, 4%. It might be a good idea at this point to make sure that students understand the units of measurement for the two variables. You could ask what a fire spread rate of 16 feet per minute means, and if they think that this is a lot, or you could ask how far a fire with a fire spread rate of 16 feet per minute would spread in just 5 minutes. You can point out that this was a lab experiment that was conducted in a wind tunnel where the researchers could control the wind speed. Students might wonder if this is realistic, and if this is an issue raised, you can let them know that they will investigate data from real wildfires later in the activity. Students are then given a scatter plot for the data. If time allows, you could modify the activity to have students create the scatter plot themselves. At the end of this module, you will be able to download a Word version of this activity so that you can easily make changes to it. At this point in the activity, you can give students a few minutes to consider answers to questions 3 through 5. Ask students how they describe the relationship in their answers to question 3. If the first student who shares gives only a partial answer, for example, just saying that there seems to be a positive relationship between fire spread rate and wind speed, you can ask if any other students would like to add to that answer. Try to bring students to a description that includes that the relationship is strong and positive, and that is in context, meaning that it's in terms of wind speed and fire spread rate rather than just X and Y. Some students may say that the relationship looks approximately linear, and others may say that they see a bit of a curve. If this does come up, you can indicate that this is a good observation and that it could also be useful to explore describing the relationship with a curve rather than a line. This option is mentioned later as a possible extension for this activity. In question 4, students are asked to make a prediction based on just looking at the scatter plot. Ask students what they predicted for fire spread when the wind speed is 7 miles per hour. If you're teaching online, you can ask students to type their prediction into the chat. You should anticipate that based on just looking at the scatter plot, most students will predict the rate of spread will be about 7 feet per minute. In question 5, students draw a line on the scatter plot that they think does a reasonable job of describing the relationship between fire spread and wind speed. If you are teaching in person, you might want to put students in pairs or small groups to compare their lines and to try and decide whose line they think is best. When you bring the class back together, you can ask students what criteria they used to decide whose line was best. This will set the stage for what comes in part 2 of the activity, where the least squares criteria is introduced. Questions 6 through 8 of Part 1 of the activity are the lead-in to Part 2, where students are introduced to least squares. In question 6, students are given the equation of a line and asked to use it to make a prediction. If you have students who need a bit of review on what the equation of a line looks like, or how they would use it to calculate the value of a y variable when given the value for the x variable, this would be a good place to take a few minutes to review those topics. If needed, you might also want to review how to plot a line on a scatter plot before students tackle question 7. The point of these questions is that the line provided in question 6 will result in a predicted value of 7, which is about the same as the prediction students will have made using their eyeball good fit line. But when they plot this line, it's clearly not a good line for describing the relationship between wind speed and fire spread rate. This leads to the final question that asks students to think about what would make for a good line. This question could be used for class discussion, and students should get to the idea that a good line is one that is as close as possible to the points in the scatter plot. That concludes part 1 of the activity. Next, we have a few questions for you to think about. Off you go!